If you've ever been out in the blazing sun without sunscreen, you know how painful a sunburn can be. Now, imagine multiplying that feeling by billions. Getting close to the sun isn't like reaching out to feel the warmth of a fireplace. It's like trying to hug a nuclear furnace that never turns off. Its surface, which isn't even the hottest part, reaches over 5,500 degrees Celsius, about 9,932 degrees Fahrenheit. And if you're wondering, but what if we went with an ultra-strong spaceship? The answer is simple. Any ordinary craft would vaporize before you could even say, "I made it." So how is it possible that, in the 21st century, humanity dared to say, "Let's touch the sun"? It sounds crazy, but it's not science fiction. It's science, technology, and a bit of boldness. In 2018, NASA launched a project that seemed impossible, the Parker Solar Probe, a spacecraft built to get closer to the sun than anything before it. And we are not just talking about passing nearby. It was designed to dive right into the sun's atmosphere. The first major milestone came in April 2021, when Parker literally touched the sun, crossing a region known as the Alphen surface. And the story didn't stop there. In 2024, it got even closer, sending back data that reshapes everything we thought we knew about our star. Before explaining the trick, it's worth understanding what Parker was sent to investigate. The sun has layers, like a cosmic onion, but with extreme temperatures. At the center is the core, where nuclear fusion reactions occur. Then comes the radiative zone, followed by the convective zone. After that is the photosphere, the part we can see, then the chromosphere, and finally, the solar corona, that glowing halo visible during a total eclipse. Now, here's the mystery. The corona, which is the outermost layer, is hotter than the surface itself. We're talking about millions of degrees in the corona versus only 5,500 degrees Celsius, about 9,932 degrees Fahrenheit, at the photosphere. It's like the air around a campfire being hotter than the flames. Something doesn't add up, and that's exactly why Parker was sent, to find out why this happens. Getting that close to the sun was only possible thanks to a real-life Captain America shield, but in space form. Parker carries a thermal shield called the TPS, Thermal Protection System, made of carbon reinforced with a special foam. It's 4.5 inches thick and works like a giant sunshade. On the outside, temperatures soar above 1,300 degrees Celsius, about 2,372 degrees Fahrenheit. On the inside, the instruments remain at a comfortable 86 degrees Fahrenheit, as if they were in an air-conditioned room. This shield not only protects against extreme heat but also from the intense radiation the sun emits. Without it, the mission would have lasted only seconds. Another thing, controlling Parker in real time is impossible. Light takes about 8 minutes to travel from the sun to Earth, so any command would arrive with a huge delay. That's why Parker is almost completely autonomous. It adjusts its position on its own, rotates the shield to the ideal angle, and decides when to take measurements. It gathers data on solar particles, magnetic fields, and space weather events that can impact everything from satellites to electrical grids on Earth. So while it might seem like it's just traveling, in reality, it's working non-stop. The launch took place on August 12, 2018, and since then Parker has made several visits to Venus. But it wasn't tourism. Each pass used the planet's gravity as a kind of cosmic slingshot, adjusting its path and speed. This dance with Venus allowed the probe, on April 28, 2021, to come within just 8.1 million miles, 13 million kilometers of the sun's photosphere. It's almost like putting your face next to a fire without getting burned, but on a space scale. And it was on that day that it crossed the Alphen surface, officially marking the moment humanity touched the sun, a historic milestone in space exploration. Parker also broke another record. It became the fastest human-made object in history. On December 24, 2024, it reached a speed of 430,000 miles per hour, 692,018 kilometers per hour. For perspective, Earth's escape velocity is just 25,000 miles per hour, 40,000 kilometers per hour. At that speed, you could travel from New York to Tokyo in less than 2 minutes. And no, that's not an exaggeration. That's pure physics pushed to its limits. But Parker wasn't just out to break records. It uncovered strong clues about the mystery of coronal heating. Magnetic waves and reconnect ion events in magnetic fields appear to be the main drivers behind the corona's extreme temperatures. It also revealed that the Sun emits far more energetic particles than we can measure from Earth. This changes our understanding of space weather and could help predict solar storms that threaten communications, power grids, and even commercial flights. Even while focused on the Sun, Parker also peeked at other worlds. During its maneuvers, it captured rare images of Venus's surface, revealed a dust ring surrounding the planet, and detected a massive plasma tail stretching behind it. And as if that weren't enough, it identified and observed 19 previously unknown comets. In other words, beyond touching the Sun, Parker also enriched our catalogue of space objects. The adventure isn't over yet. In March and June of 2025, Parker will make new approaches, possibly faster and closer than ever before. When its mission finally comes to an end, it may be directed to dive straight into the Sun, burning up completely, with only fragments of its thermal shield remaining. Even so, it will forever be remembered as the first human-made object to touch our star. Touching the Sun. Who would have thought such a poetic phrase could become a scientific reality? The Parker Solar Probe proved that, with technology and courage, even the most extreme limits can be reached. Now tell me, if you could send a probe anywhere in the universe, where would it go?